Today we're looking at Glencoe Accelerated Math, Lesson 5-6 on graphing proportional relationships. Now we know that we're looking at our standards on ratios and proportions, and you know that in this book we also cover some of our 8th grade standards. Well, our 8th grade standards ask us to graph and analyze. The 7th grade geometry standards only ask us to be able to analyze. So we're going to do both today. Okay? The first thing that we have to do are recognize what makes a graph proportional. Because you can graph just about anything. But we need to know what makes a graph proportional. I want you to look at the two lines, the two graphs on page 212. One of those is proportional, one of those is not. Anybody want to give a guess as to which one might be proportional? Yes, ma'am.
The red one.
Why do you think the red one might be proportional?
Because it's going in like a straight diagonal line.
Okay, so you say it's going in a straight line?
No, like it's like going from corner to corner.
Okay. But it's in a straight line? Yeah? Okay. What else can you tell me about the two graphs on page 212? Which one do you think is proportional and why? Yes, ma'am.
Because they're going up by 10,000 each time, I think.
The red or the blue?
The red.
Okay, so you also think the red, and it's because it goes up by the same amount each time? All right. What else? There's one other difference between the two graphs. Yes. Okay, so the red one starts at the point 0, 0. What do we call the point 0, 0? The origin. There's one more thing, but both of these graphs do that. It also has to be increasing. So, we know that center B is proportional because I'm telling you that. Okay. You guys were able to infer that. I am telling you were correct. Line A for center A, the blue one. It meets some of these conditions, but it does not meet all of them. Because if we look at that non-proportional graph there, it is a straight line, and it is increasing. That means that our numbers keep going up. But it does not have a constant of proportionality. It doesn't have something where we can divide our y by our x and get the same number every time. What did we call it? What was another way that we called that constant of proportionality? Started with a u and then an r.
Unit rate.
The unit rate. Very good. If you look at center A, that blue line, and you look at those points, I'll give you a second to write in just a second. Does that have a unit rate? No, it's not. The unit rate changes, doesn't it? Okay? If that's true, then we don't have a constant of proportionality, which means it's not proportional. Alright? The third thing, it has to start at the origin. It has to start at an origin. For things to be proportional, that means that if we buy 6 of something, then we pay X amount. Right? Okay. If we start somewhere up on that y-axis, that means that if we don't start at the origin, that means that we are paying for something, but we're not getting anything. Do we want to do that?
No.
No. If you don't believe me, go check the Verizon commercials, okay? So it has to go through the origin for it to be proportional. When we graph data, we know that our we have two axes. We have the x, we have the y. How could we find the constant of proportionality or the unit rate from a graph? Yes.
You can find where you divide it.
Okay.
Add and divide.
So I could divide the y value by the x value and find the unit rate at multiple points, correct? Is that what you're saying?
Well, you add all the points. You find.
I can find the average.
Yeah, the average.
Okay. Average works for a lot of things. Average does not work for this. Okay? Anybody else? Alright, I have a sketch of a graph. It's a sketch, that means it's not perfect. Are things labeled? Yeah. This would be the point 1, 2. This would be the point 3, 4. My unit rate, which is my constant of proportionality, is going to be whatever my y value is when x is 1. So if you have a graph where the 1 is given, where you know what x is at 1, that means that you are given the unit rate. That means that you are given the constant of proportionality. Which means you don't have to calculate it. Should we calculate just to make sure?
Yeah.
Yeah. But that's a good check for us. Alright? What questions do we have real quick? We're good to go? You don't get it? Okay. Let's look at example 1. It says to determine if the relationship is proportional by graphing. And in example 1, they went ahead and they graphed for us. Woohoo! So, what we've got, we're looking at time and distance for the black mamba, which is the fastest snake in the world. The table gave us distances that were calculated. Now we had to graph it. And when it's graphed, here's our graph. We see that we have points 0, 0, 1, 5, 2, 10, 3, 15, and 4, 20. So in 0 seconds, how many meters did this snake travel? 0. In 0 seconds, it traveled 0 meters. Guys, it would be really scary if we traveled some number of meters in 0 seconds, right? Okay? So, that's what I'm saying. It has to go through the point 0, 0 for something to be proportional. Alright? So, can we check off starts at the origin? Yeah. Let's go ahead and check it off. Ta-da. Okay. Is this graph increasing? Does it go in a straight line?
Yes.
Yeah, we can check that off. It goes in a straight line?
Yes.
Yeah. Does it have a constant of proportionality?
Yes.
Okay, what is my constant of proportionality? Yes, ma'am.
+1 on that.
Okay, so in 1 second, how far is the snake going to travel?
It goes 1 meter per. It goes 1 meter per 5 seconds. 5 meters per 1 second. 5 meters per 1 second.
Okay, it goes 5 meters per 1 second. So what is my constant of proportionality? 5.
Oh, yeah, that means.
When we look at speed, we're looking at the distance divided by the time.
Oh.
Okay? So we'd be looking at meters per second. Just like on speed limit signs it says miles per hour, meters per second. So what is that constant of proportionality again?
5.
5. And it has a constant of proportionality?
Yes.
is this relationship proportional?
Yes.
Yes. Could you tell me how far I can expect the black mamba snake to travel in 20 seconds?
Yes.
Yeah.
40 meters.
40 meters. Very good.
Meters.
Okay. Is that better? Little bit?
Yes.
Little bit? Okay. Yes. At the end. All right. I want us to look at example 2. Example 2 asks us to analyze. So this is saying we already have our graph. If we already have the graph, what can we learn from that graph? So if we have a graph that's already given to us, put it away. We can do a lot of things. This says that the length of a stretch in millimeters of a spring is proportional to the weight in grams attached to the other end of the spring shown on the graph. So, we're talking about a spring. Think about what's in the end of a clicky pen, okay, a spring, and you can pull them and, tighten them. That's how the clicky pen works. Talk about a spring. If we're given the graph shown, we need to find the constant of proportionality. What is that constant of proportionality in example 2 on page 214? Yes, sir. You don't want to give it a try? Yes, ma'am?
5.
You say 5. Can you include units with that for me, please? Y comes first. Per 5 millimeters per gram. Good. What does that 5 millimeters per gram mean? Yes?
That's how many millimeters it stretched. Wait, that's how many millimeters it stretches by per gram.
Right. So for each gram of weight that's added, we can expect the spring to stretch 5 millimeters?
Yes.
Alright, good. Well, right now you're saying, why would that matter? Right? Some of us,
No.
Okay. being able to do this is going to be important.
Right.
What?
I said right.
Okay. Now, if I asked you what the point 525 means, what does that mean when I graph the point 525? Somebody I haven't heard from yet. Go ahead.
It means that you moved 5 and up 25?
Okay, so it means I moved over 5 and up 25. In terms of this problem with my units, what does that tell me? Go ahead.
It means with 25 millimeters per 5 grams.
Very good. It means that with 5 grams of weight, the spring is going to stretch 25 millimeters. What questions do we have? Guys, this is something that just takes practice. You think it's easy? Okay.
Yeah.
Any other questions about this? Alright. If we look at example 2, if we're not told that it's proportional, do we have to run through our checklist first?
Yes.
Yes. Because if it's not proportional, then we can't find out information unless those data points are given. Okay? Alright, thank you.